Today we're going to learn how to solve using I and using inverse operations. This is the end of section 3.2. I've done a series of 5 examples ranging from easy to hard as normal, so hopefully this will be helpful. The first example is x squared plus 4 equals 0. Now we know we have to do the order of operations in reverse order, thus being an inverse. So our first step is going to be to get rid of the adding 4 by subtracting 4 from both sides, thus yielding x squared equals negative 4. Now to get rid of a square, we have to square root both sides. Don't forget your positive or negative. But at this point, up until now, we would say it has no real solution, which it doesn't. It has an imaginary solution, actually 2 of them. So in order to do this, what we have to do is take the square root of 4, which is 2, and the square root of the negative, which is I, and the answer becomes positive and negative 2i. Let's try another one. This one, we start the same way, by getting rid of the minus 11 from both sides. To get rid of the minus 11, we add 11 to both sides, thus giving us 2x squared equals negative 36. Then we need to get rid of the 2 in front, so we divide both sides by 2, giving us x squared equals negative 18. Now, just like the last one, we're going to have to square root both sides, not forgetting our positive or negative. There is no pretty perfect square root of 18, so we have to find the largest perfect square that goes into 18, which is 9. 9 times 2. The square root of 9 is 3, with a leftover square root of 2, so it's 3 square root of 2, or 3 radical 2. But since there's a negative inside, we say 3i square root of 2, or 3i radical 2. Now notice I do have a positive and negative in front because it's positive 3i squared root of 2 and negative 3i squared root of 2. Let's try some with some parentheses. I find the parenthesis ones to be the hardest, so we'll take our time and slowly go through them. Number 3 states 8 times the quantity x minus 4 quantity squared equals negative 24. Step 1, divide by 8 on both sides. That will cancel the 8's out, leaving me negative 24 divided by 8, which is negative 3. Now we can't get rid of the minus 4 because parentheses are always less when we're working backwards. So now we need to get rid of the square. To get rid of the square, we're going to square root both sides, putting in a positive and a negative. Now at this point, of course, we would say there's no real solution because there isn't. It's an imaginary. Actually, it's going to be an imaginary complex solution. Can't take the square root of 3. 3 cannot simplify, but that negative can come out in front as an I. So 1i square root of 3, or I square root of 3. Now I have to get rid of the minus 4. To get rid of the minus 4, we add 4 to both sides. Reminding ourselves that we can't add an imaginary to a real, so we have to leave them as separate. So we're going to write our answer as a complex solution. We always list the real number first, followed by the imaginary. So it's 4 plus or minus I square root of 3, or 4 plus or minus I radical 3. So if I wanted 2 separate answers, it'd be 4 plus I square root of 3 and 4 minus I square root of 3. Let's try one more of this type. Now this one has many steps, and it's by far the hardest one you'll have to conquer. It says negative 2/9 times the quantity 3x minus 4 quantity squared equals 3. Step 1, we got to get rid of the negative 2/9, so we divide both sides by negative 2/9. To divide both sides by negative 2/9, we multiply both sides by negative 9/2, the reciprocal. Now when I do that, I end up with something like this. Now there is a little typo. This should be a 9 here, not a 5. So we multiply both sides by negative 9/2, reminding ourselves that we want our answer in most simplest exact form. So 3 times 9/2 becomes negative 27/2. Just like before, we're going to get rid of our square by square rooting both sides, not forgetting our positive and our negative. To square root a negative 27 halves, we bring it out as an I in front, and we're going to simplify that. So in order to do that, I'm going to rewrite it. I'm going to separate it by rationalizing my numerator and my denominator by 2, the square root of 2. Square root of negative 27 times 2 is negative 54. Square root of 2 times square root of 2 is square root of 4, which is just 2. Now, square root of negative 54 can actually simplify. The largest perfect square that goes into 54 is 9, and the square root of 9 is 3, so it's 3 square roots of 6. Noticing I did, at this point, put out the I. Now, if you wanted to, you could have put out the I straightforward right up here at the beginning, but I just hung on to it for a while. Well, now if I wanted to solve this simple two-step problem, I have to add 4. But if you remember, this is an imaginary number over here, so we can't add a real number to an imaginary number. So here's where I put 4 plus or minus 3i square root of 6 over 2. Now to get rid of the 3, we're going to divide both sides by 3, which is the same thing as multiplying both sides by 1/3. Not forgetting that everybody gets the 1/3. So 1/3 times 3x is just x. 1/3 times 4 is 4/3. Now this becomes kind of crazy, so I'm going to look at it just as 3 halves. 3 halves times 1/3 is 3/6. So we end up with something like this. Now I do know that 3/6 simplifies, and you could combine steps, but I just simplified it separately. So 3i squared is 6 over 6 becomes I squared is 6 over 2. So we have 4/3 plus or minus I squared is 6 over 2. Or you could have 4 plus or minus the square root of 6 over 2 times I. Normally I just leave it up top. One last example reminds us the meaning of zeros. Remember, zeros are your roots, which are your x-intercepts, which are basically solving for x. So if they give you a function, remember f of x is just the same thing as y. We can actually solve this math problem more than one way. Now, if we were to try to graph it, I will tell you now, it would never cross the x-axis because, of course, we're working with imaginary solutions. So that doesn't help us. But what we can do is work backwards and find those imaginary solutions. So step 1, I replace f of x with 0. Now, if you want to, you can rewrite this so that it equals 0 on the right, which is fine. Now we're going to subtract 1 from both sides. 0 minus 1 is negative 1, so we're at negative 1 equals 9 times the quantity x minus 2 squared. Now I can't get rid of a square until I get rid of multiplying whatever's in front, so I divide both sides by 9, or basically multiply both sides by 1/9. Now when I do so, I end up with negative 1/9 equals x minus 2 quantity squared. Now we work our way in and we get rid of our square by square rooting. The square root of a negative is I. The square root of 1 is 1. The square root of 9 is 3. Now if you need to see that, this is kind of what it looks like if you lay it down side by side. Okay, so we said it was 1/3 and an I. So I have 1i over 3. Or you could say 1/3 I. Then I get rid of the minus 2 by adding 2 to both sides, but I can't add a real answer to an imaginary. So I keep them separate. So it's 2 plus or minus I over 3 equals x. Now you could have 2 plus or minus 1/3 times I equals x. And it means the exact same thing. Or 2 plus I over 3 and 2 minus I over 3, because those are two complex solutions. I hope this is helpful. Now it is your turn.